Hello, I'm going to give you a quick example on how to do partial fractions with this single example I have in front of me right now. So partial fractions you can think of is the reverse process of adding algebraic fractions. So rather than having two algebraic fractions, creating a common denominator and adding them together, we want to remove this process, so we want to do it backwards. And this will allow us to split a fraction such as this one into multiple fractions, and this can be useful, for example, in integration, where it's harder to integrate something like this because it's quite large, but it's easier to integrate smaller fractions, algebraic fractions, if you know how to do them. But partial fractions aren't just used in integration, they're very important in other areas as well. So we start by saying this is equal to 1 over, and what we want to do is we want to factorize the bottom half, and this quadratic is quite easy to factorize. So this is just x plus 2, x plus 3, like that. Okay, next we have to write out our partial fraction as so. So we've got x plus 2, x plus 3 is equal to, now we're going to write a over x plus 2 plus b over x plus 3. Now you may be wondering why I just introduced two new variables, because this is already difficult to do. Well, actually this makes it a lot easier to do, and you'll see why in a second. And we don't know what a is, but we know that it's some sort of number. It could be negative, it could be positive. For this example, there are more advanced examples when you don't have linear factors, but we won't worry about these. So for example, a could be anything, b could be anything, so we're going to work out what a and b are. So how can we work out what a and b are? Well, what we have here is a fraction, so a sensible move might be to multiply out by x plus 2 times x plus 3. So if we do this, we'll get 1 is equal to, and then the x plus 2 will cancel with that x plus 2, and we'll get a times x plus 3. And the same will happen, but with the x plus 2 instead, or the x plus 3 instead, with the b, and we'll get bx plus 2. Now, an important thing to note is that we're not solving an equation for x, because x actually satisfies, this is an identity, and by an identity we mean that for any value of x this holds true, which means we can actually plug in some values of x in order to find out what a and b could be. So let's start by looking for some cancellations. What kind of x value would give us some nice cancellations? So one really obvious one that we could try is if I substitute x equals minus 2, this will become 0, and that will eliminate the b term, and this will mean that x plus 3 goes to 1, because 3 minus 2 is 1. So what we get is 1 is equal to a. So now we've just found a, and this works for any value of x, so we don't have to worry that we plugged in x minus 2. X equals minus 2. Okay, so now let's have a look at what happens if I plug in x equals minus 3. Well, what we get is 1 is equal to, well, this a term will all go to 0, so we'll just be left with this b term here, and minus 3, so we've got 2 minus 3, that will give us minus 1. So actually minus b is equal to 1, which can also be written as something like this. Minus 1 is equal to b. Now that we found the coefficients that we needed for the partial fractions, we go ahead and write them in. So let's see if I can fit this all in. 1 all over x plus 2, x plus 3, like that, is equal to Well, now that we know what a is, which is 1, so we can just write 1 over x plus 2. And finally we can write what b is, which is minus 1 over x plus 3. Notice how I wrote the minus there because it's just on the top. Okay, so there we go. We've actually completed what we wanted. Now, to check that this is even, you don't always have to check, but if you really want to check that this is true, we can go ahead and add these algebraic fractions. So getting common denominators, we get x plus 3 all over x plus 2, x plus 3, minus, and remember we're timesing x plus 2 here, so it's going to be minus x minus 2. Okay? And we know that these x's are going to cancel, and this 3 is going to get subtracted, leaving us just 1, which is our original fraction that we wanted over here. So this is a very simple partial fractions example, and this only will work if you can factorize the bottom polynomial into linear factors. It will also work for more than a couple of factors, so you just write them each out for each factor. I might do a video on when some of the factors are not linear. Thank you for watching.